Hello, grade 8 learners. Welcome to our lesson today. My name is Tutu Masudubele, and we'll be doing exponential equations part 2. So this is a continuation of our previous lesson. Now, without any waste of time, grade 8 learners, let us get into the presentation. These are just some of the questions that we'll be going through. I'll be explaining the procedures on how to solve these equations so that you're able to apply this knowledge in your classes. Now, here's the first one, grade 8 learners. We have 7 to the power of y is equal to 343. Now, what we need to do here, grade 8 learners, is that we need to get both bases to be the same. If you look at the left-hand side of the equation, we have 7 to the power of y. Already that base is a prime number. 7, remember, is a prime number because it only has two factors, which is 1 in itself. So in terms of 343, we then need to express 343 as a base of 7. And by doing that, grade 8 learners, what you do is that we prime factorize. So if you prime factorize 343, it will come out as 7 to the power of 3. Or in short, it can be written as 7 multiplied by 7 multiplied by 7. So in exponential form, it will be given as 7 to the power of 3. Now notice, grade 8 learners, that we have bases that are the same on both sides of the equation. We have a base of 7 on the left, we have a base of 7 on the right. Now the minute our bases are the same in an equation, all we need to do is that we need to equate the exponents. So therefore, the exponent of base 7 on the left-hand side of the equation is y, while the exponent of base 7 on the right-hand side of the equation is 3. So therefore, all we need to do, you drop your bases and you equate the exponents. And there we found the value of y. Y will be equal to 3. Very important that you get the bases to be the same. Now here's a second equation, grade 8 learners, a second exponential equation. And again, just like the previous example, we need to get both bases on both sides of the equation to be the same before we equate the exponents. That's the general procedure of solving exponential equations. Now, if you notice on the right-hand side of the equation, you have a base of 1. So we need to find a way of expressing this 1 as a base of 13. Now, what do you remember, grade 8 learners? Remember the definition that says any base raised to the power of 0 will give us 1. So therefore, because you already have 13 as a base on the left-hand side of the equation, we can express this 1 as a base of 13. So that can be given as what? As 13 to the power of 0. You will realize that any base to the power of 0 will then return back to 1. So now that we have equal bases on both sides of the equation, what do we need to do, grade 8 learners? We need to equate the exponents. The exponent of base 13 here is x minus 4, while the exponent of base 13 on the right-hand side of the equation is 0. So as we equate the exponents, we'll have x minus 4 equal to 0. And now we need to isolate for x. We need to find what the value of x is. And to do that, grade 8 learners, realize that the constant here is negative 4. How do we get rid of that constant? Well, to get rid of negative 4, we need to add the additive inverse of negative 4. And what's the additive inverse? It's positive 4. So we do that on both sides of the equation. Realize that we've added 4 on both sides of the equation in order for us to isolate for x. And by doing that, x will then give us 4, because 0 plus 4 is equal to 4, while negative 4 plus 4 gives us 0. Right, let's go on to the next question. Here's a third exponential equation we have for you. We have 8 to the power of p is equal to 32. Remember what I said, grade 8 learners. It's all about getting bases on both sides of the equation to be equal. So now, is it possible for us to express 32 as a base of 8? And the answer will be no. But if you realize this base of 8 on the left-hand side of the equation is not a prime base, because 8 is not a prime number. So what do we need to do now, grade 8 learners? We need to prime factorize both bases. So the prime factors of 8 will give us 2 multiplied by 2 multiplied by 2, which can be given as 2 to the power of 3, while the prime factors of 32 will be 2 multiplied by itself 5 times, giving us 2 to the power of 5. Now we have expressed 8 as a product of its prime factors, as well as 32 as a product of its prime factors. Now realize we have brackets again, grade 8 learners. And one of the laws of exponents tell us that if we are raising an exponent to another exponent, all we need to do is to multiply the exponents. So we need to get rid of those brackets by multiplying the exponents. Remember your laws of exponent, grade 8 learners. So 3 multiplied by p will give us 3p, so we therefore have 2 to the power of 3p equal to 2 to the power of 5. Now realize that we have equal bases on both sides of the equation, so we equate the exponents. Now realize here, grade 8 learners, p has a coefficient now that is not 1. The coefficient of p here is 3. So what do we need to do to get rid of this coefficient of 3 in order for us to isolate for p? All we need to do, grade 8 learners, is to multiply by the multiplicative inverse of 3. And what's the multiplicative inverse of 3? And you will know that it's a third. So we then multiply both sides by a third in order for us to isolate for p. So as we do that, p will then give us 5 over 3, which can also be written as a mixed number as 1 and 2/3 as well. Now let's get into the fourth exponential equation, grade 8 learners. Now this one seems a little bit more challenging than the ones we did previously. So all we need to do here, grade 8 learners, remember we're trying to solve for the exponent, in this case in being k. The golden rule is to always get our bases to be the same. And before getting your bases to be the same on both sides of the equation, you need to ensure that you've isolated for the exponential expression. So in this case, we have 3 multiplied by 5 to the power of k plus 1 is equal